All right, can y'all hear me all right? Perfect. All right. Thank you so much for joining us for this roundtable, and thanks for coming out to Vulkanized, of course. Great to see so many familiar faces here. We have a great roundtable for you today. What we're going to talk about here is tools, platforms, SDKs. We have a great group of people here that are going to represent all those different things, but we're not here to tell you about what our problems are. We want to know what your problems are. And so the way that we're going to structure this roundtable is we have a great group of panelists here. We're going to do introductions in a second. They're going to, we have basically a what I call a conversation map, which is a bunch of potential, waypoints that we can go to keep things moving along. But I want you to drive the conversation. So I want to hear from developers out here in the audience that are running into problems, your pain points, the things you experience every day, where if you only had that tool or that feature in the tool, it would be saving you a lot of time. Let's see. If the conversation becomes productive and we start going in some direction, I'm going to let it go there. I'm not going to stifle the conversation and keep us onto the agenda if we have good things that we're talking about. But we only have an hour. That sounds like a lot. That's not a lot to talk about what all the things we want to talk about today. So if we do slow down, I have a lot of backup questions. We'll keep it going. One request I would make is try to keep things concrete and not super abstract. I know we can come up with lots of great problems theoretically, but it would be great to hear about things that you've actually experienced in your day-to-day. I think that's going to help us come up with some good solutions much more effectively. So with that, we'll start with some introductions here. So who am I? So first, I'll introduce myself. I'm Aurelia Reese, Director of Graphics Developer Tools at NVIDIA. In a previous life, I was a developer and I worked on games, and I actually worked on one of the first Vulkan titles at a company called Super Evil Megacorp. 30% evil. They weren't that bad, but it was a game called Vainglory. And we actually worked with Samsung to get, I think it was like one of the first implementations of it way back in 2016. So I have a little history with Vulkan, but I'm not an active developer day to day, so don't ask me hard questions. But I can tell you a lot about NVIDIA's perspective on tools, what my team does, and kind of at least give you my perspective on it. So I'll pass that along to, I was going to do in order, I guess I'll do that. So we'll start with Brad from Lunar G.
Sure. Yeah, my name is Brad Grantham, and my job is the architect and kind of the person whose butt you kick for Graphics Reconstruct, the capture replay package for Vulkan. So that's sort of my day-to-day job, just trying to keep that on track and make sure it's doing everything that everybody wants it to do.
All right, Emra.
Hello, I'm Emre, and I'm a software engineering manager at Google, and I work on, my team works on profilers for Android. This includes app side and as well as the games and graphics and GPU side. So anything related to Android and profiling and debugging apps and graphics and Vulkan on Android is included in my interests. So thank you.
John.
Hello, my name is Jonathan Litt, and I work with Aurelio. I'm the product manager for graphics developer tools at NVIDIA. So that covers Nsight graphics, Nsight Aftermath, parts of Nsight systems. If you've used Nsight systems, it has some functionality specific to graphics analysis. And we have some other tools as well. There's something called Nsight Perf SDK, which is a library you can incorporate into your apps. And I also, in a previous life, I did more hands-on development. I've used all the graphics APIs, more so in the past. I've used a lot of tools, a lot of RenderDoc in the past, a bit of Perfetto as well. But it's been a few years since I used that. So looking forward to the panel.
Simon.
Hi, I'm Simon Cook. I'm in Google Games DevRel, and I'm also bolted onto Emery's team, where we work together on profilers and game-related tools. And in a previous life, I worked at Midway Games on a few different games. I ended up at Xbox in their advanced technology group for a decade, and now I'm at Google.
Spencer.
Hi, I'm Spencer Fricky. I'm the validation layer tech lead. So I also somehow crawled into many other ecosystem tools. I've touched outside Vulkan Video. I think I've touched every other part of the API at this point, having to do validation layers. So yeah, that's my experience.
All right, and finally, Warren.
Yeah, my name is Warren Paul. I run the tools team at SARC, which is Samsung Austin Research Center. We make the Xclipse GPU. I've been doing developer tools for nearly 3 decades now. So one of my passions is to make people like your lives easier. We can really do that with good feedback. So I'm anxious to get this going and hear what you have to say.
Awesome. Appreciate it. Thanks so much, everybody. And by the way, we tried to get Balder in RenderDoc. He wasn't able to come out, but I love having conversations with him about RenderDoc and kind of the future of it. And he always likes to keep telling me it's not a profiler, but I think it's going to be a profiler one day. All right, so we're right on time. We're going to start with core pains that developers are facing, some of the core challenges that they're experiencing in the Vulkan ecosystem. And so I'll start with a simple question. Let's see, who am I going to pick on? We'll start with you, Warren. What Vulkan issues do you think waste developers the most amount of time?
That's a good question. I'd rather hear from the audience on that one personally, since I'm not a Vulkan developer myself. I'm a tools developer, but I think the initial setup. When I first got into Vulkan, really just a few years ago, I looked at the sample and 700 or so lines of code to render a triangle, and I was like, wow, that's a lot of setup. So I think a lot of the presentations we saw earlier today with the simplified headers, I think probably does a lot. The samples help a lot. The validation layer obviously helps a lot. So I think just getting started with a pretty complex full API is difficult.
I mean, the idea, the syntactic sugar and the defaults, I think that's interesting from the core coding perspective, that it reduces the problem scope. But from a tooling perspective, is there something that we could be doing more to be providing, I think, like helping manage the complexity of the API, maybe documentation, maybe one of the Google folks mentioned Gemini and Android Studio, right? So that's kind of an interesting way to approach it.
So I think on the documentation standpoint, one of the things that I've noticed, at least for the last 10 years, has been that a lot of our documentation assumes that you're an experienced OpenGL developer who understands everything about HLSL or GLSL, and you've been developing a whole bunch of OpenGL code for decades. And unfortunately, in the industry right now, a lot of the engineers who understand all of that stuff are beginning to age out and retire. So we kind of need to build new on-ramps for new developers to come in and essentially build up their chops.
I'll add something. One thing I like to think about with developer tools and debugging tools is not even necessarily think about them as something you do after the fact to profile, develop, analyze, but just to learn. I remember not having any tools like that in the past, and then over the years they started to appear, and that would just be the first thing I would do with the new graphics app, is just open it in one of these tools and use it essentially as my intro. I'd go straight there rather than looking at the source code. And so I think maybe that's also something we could improve on our side. I'm not sure specifically how, but using the kinds of tools that we make on this panel to onboard people onto the ecosystem as well. Open to any feedback on how that how that could be done.
Yeah, I mean, I guess this is kind of maybe the first question posed to the audience here. And by the way, yes, just raise your hand. We'll get a mic too, so you can so we can hear you. Is this a situation where there's kind of a hump you have to get over, a huge learning curve, And then once it becomes manageable, you're able to be more productive, or are you constantly running into these kinds of problems and you just wish that, maybe it surfaced in the UX, or maybe there were other ways that the complexity could be managed from a tooling perspective?
Over the years, I've fired up a few different of those graphics debugger tools. They're always amazing when I understand what I'm doing. However, there will always be parts in the UI that either are new or just new for the problem that I'm working on. And then the biggest thing that I'm looking for is being able to hover over a thing and having an explanation. Like if there's a text that tells me warp divergence and I have not heard of the concept before, then I would like to be able to hover over it and get at least a single sentence telling me what the hell is going on.
Yeah. It's funny. I have a name for that on my team. I call it the 747 cockpit problem. And so if you ever have to, I don't know, they show it in movies, I guess, but if you ever have to land a plane, unless you're a really experienced pilot, you're not going to do it. There's a lot of buttons everywhere, and one of them lowers the landing gear and the other probably dumps all your fuel, right? I don't know. So a lot of times, so speaking from my experience, Insight Graphics has GPU Trace, this, advanced profiler, and it very much maps to the NVIDIA hardware. And so you have a lot of hardware units, you have throughput and latency hiding that you want to really expose with, maybe showing stall reasons and at the shader level, instruction level, and all the different layers that you have to kind of peel through to basically take a tremendous amount of information and then distill that into, what do I change in my code? It takes so much context. You have to know so many different things in different places. I think that's one of the challenges that, we want to hear from developers about is how do you take some of these, the tooltips is a great point. That's one way where if you hover over something, we can inform you a little bit better, but you're going to be hovering over a lot of stuff. There's so many things in the cockpit that how do you relate all of that and distill it into something that is manageable and that you have actionability with it?
Are you using AI now to get any of that context? Like, I feel like this is an opportunity, right? Because the tool, if you're using a tool, it at least has the commands that you've called potentially. It's got information about the style of the commands and the data, any errors that you have. One of the experiences I've had with AI lately is it's been super powerful if you already know something about the material, because you have to be able to tell it, don't invent things and go back to the original documentation. So that's an opportunity for us, I feel like, as tool users, that those tooltips, if they have the right prompting behind them, could give you some really great information.
Yeah, I suspect that like the 747 cockpit analogy, like there's a lot of different plane models that we all have, right? And each one has its own set of switches. So I can only imagine going across all these different GPU vendors. So I think there's a lot of hope for a sort of a common framework where we can expose the core interesting bits in a platform agnostic way.
I think figuring out like a big challenge is going to be figuring out how to expose data that's in the tools to a model context for AI, right? I mean, you don't want to have to go type stuff into your own model. You want somehow data in the tool to be feeding into it. It's something we're thinking about right now, but it'd be nice. I don't know, maybe we need to have like a universal language for graphics developer tools talking to an AI model, because you're trying to feed it some kind of representation of what's happening, and they're all, all these models are text-based. So the more they could find some kind of common structure, the more the models could be, built up in unison. So something we're thinking about.
I'm gonna throw a grenade into the room. All right. So at what point does that problem expand when you start introducing extensions? We could talk about kind of vendor neutral or vendor specific extensions, but the surface area is expanding dramatically. And I mean, I'll start by asking the audience this question. Is this a problem that is resulting in problematic interactions with all these extensions? And from a tooling perspective, is that something that we can be helping with by exposing more information, by talking about those interactions between different layers and different extensions? Is this something that developers tend to run into quite often, or is it something where you try to manage that by just, I don't know, defensive coding.
I think it's never a problem until it is. And right, everything will be going fine. And then suddenly it's like, well, wait a minute, why doesn't this tool support this thing? Obviously, everybody should support this thing because that's what I use.
Yeah. I think it's kind of one of those problems too, where it's like, is extension awareness a problem that the tool should be responsible for? Going back to this idea of, is there a way to draw more information, the tooltips, or maybe AI kind of being involved in telling you more about these interactions? Is that something where at some point the problem becomes unmanageable and you're just wasting a lot of time and effort on something that you need, I don't know, a specialized expert to kind of inform you what you need to do?
Yes.
That's a rhetorical question.
I think the something that would be pretty neat if tooling could be plugged into what's happening on your specific system. And with Vulkan, you might use the configurator to enable layers. Something we run into all the time is if an app was built with debugging, well, if it was built for debugging or release, can greatly change the way that what is actually happening in the app at runtime. That you're doing something in the tooling, and then you open up a different build, and the tooling works differently. These are the kinds of things that different extensions might get loaded as well, depending on the build you're running and maybe the target platform, that sort of thing. But yes, greater knowledge of that, I think, by the tooling would be helpful.
But we lose determinism, right?
Yeah.
As soon as you put yourself in that situation, like how do you kind of reframe it in a place that you can have that degree of determinism so that these kinds of problems are reproducible and you can create tests for them too?
Maybe that's a place for me to jump in. I mean, you could capture the stream.
Yeah.
It
was a trap.
Yep. Fine, walked into that one. So in that vein of the extensions, I just wanted to say I've also experienced, like our team has experienced this issue with the extensions. How many people have done the ray tracing extension in their code? Okay, so you've had to deal with these opaque descriptors for shader group handles and buffer addresses inside other buffers. Descriptor buffer, anybody? Did a little too new. It's already deprecated, right? So Graphics Reconstruct is the foundation for a couple of tools, including SOHCAHTOA. And so we've had to do this process of capturing extensions. And from our point of view as users of those extensions, they've been pretty difficult to deal with because if you, like we save them to a file and then you can replay them. And if you do that on the same implementation, it works great. But if you try and replay it on any other device, for example, for testing, you want to capture a test for your application and replay it. You can only replay it on the same implementation that you captured it on because buffered device addresses can move around. And even if you use the extension to lock them in, they'll move depending on the version of the driver. So it's an ongoing problem, just part of the job.
I guess I'll just say one of the hardest parts about validation layer development for me is I can't say no to an extension. I can't say I'm just not going to support it. We got to validate everything. As hard as it is for an app to probably have multiple paths depending on what extensions are exposed, a tool having to support descriptors, classic descriptor buffers, and now descriptor heaps. That's 3 paths in a tool as well. So there's also a load on tools when we add more extensions, not just for the developers. And I can imagine not every tool has someone dedicated to just making sure they support every extension.
I love descriptors classic.
Descriptor. That's the enum name in validation layers. It's classic.
So this might be a loaded question, but what's easier to debug today than 5 years ago?
What's easier to debug today?
Has the tooling improved so that we had these previous problems? Like you want to make sure your ecosystem's like improving over 10 years, and we'll go with 5, I guess. There has to be things where the tools are making certain things easier. If the complexity of Vulkan is expanding so substantially that even the tools can't keep up with it, I think the problem just keeps expanding and growing for developers, and it just makes it more difficult for them in the long run. So I'm trying to think about You know, I'll give you an example. So with Insight Graphics, obviously ray tracing is incredibly important, and we want to make sure to drive that. Acceleration structures, right? That's a hugely important part of creating a performance scene. So we spend a lot of time and effort to create a tool that lets you, introspect and be able to visualize, analyze, and then even some profiling features associated with that. That's one of the areas where we spent a lot of time trying to, invest in the ecosystem. Are there other areas where developers here, you found that things are easier? I hope so. Or is that just like a complete fallacy and no, things have just gotten much more difficult because of the complexity increase?
I guess I'll say, like, for going back to the descriptors, I mean, I like to believe validation does a much better job of giving good information about, if you're just about errors around your classic descriptor mismatch and all that stuff. I think the next problem we're gonna have to solve is, hey, everything's a pointer now and you're in descriptor heaps. Like, do we need to build like a visualizer to like understand what's going on? So it's almost a different problem. But I like to believe, like, the standard, like for validation at least, the standard classic descriptor model, I feel it'd be a good job helping people with that. So it doesn't go to waste, I guess. It's still there.
Yeah, luckily the visualizer problem also applies to compute. So as soon as you start debugging that, and with a lot of game engines now moving towards software rasterization and compute-driven pipelines, it's becoming more and more important to look at that as well as the like traditional fixed function pipeline that people have been using so far.
Also, crash debugging, I think that's going to be big, and it's only going to get bigger as there's a move to more pointer-like, functionality. So
yeah, we call it a GPU. I like the term GPU centric. We've moved more and more to the GPU. So when things crash, it's like, it's harder to figure out what's wrong. And I don't know, there's gonna be a lot of tools. I know it's easy for the vendors. They'll talk before about if you have access to your driver, you're like developing on Mesa or something. It is nice because you can turn on these driver tools to, like, sync all the cache flushes, and then, oh, so maybe this is something, gives you more, and yet another hint of what's going on. Because ultimately the tooling is just a toolbox. You're trying to slowly narrow down, the possibilities of what's wrong. It's a synchronization problem, caching problem. Did I just totally forget to load the memory? You try and narrow it down. And once you know it's roughly in this area, then there's like another tool that might help you do that. So
I'm really curious about the implications on the Android ecosystem too, because at scale, I feel like this problem becomes much, much worse. And so, from our experience, you have something like Insight Aftermath, and it's user facing. It's primarily development, but there's a user facing aspect where you get these crash reports you can get from the wild, and the correlation can be spotty. Sometimes you get a direct line to something, and other times you don't know where to go. Is that something that you run into quite often in the Android ecosystem? And are there, the crash diagnostics layer, other things that are helping with that, or is it just compounding as things get more complex and things to all turn into pointers? That's not going to make the problem easier.
Yes. Yeah, honestly, crash debugging, I mean, historically, it's been a big problem for Android because it was just very difficult to get anything out of the driver. And often you'd get something little more than just an error message. More and more of the vendors are starting to support the debug output, the crash reporting output APIs. So we're finding that, like, we're at least getting to the point now where you can get some kind of GPU state tombstone that comes out, kind of like Aftermath and libraries like that. So it's improving, but we're probably, because obviously there's lead times, it's going to be a while before the problem's resolved.
I want to ask the audience actually. So, who here would say GPU crashes are your number one problem? Okay, that's maybe 15, 20% of the audience. What about performance? That's like 50%. General graphics issues.
like rendering artifacts.
Rendering artifacts, thank you. Like 20%, okay. Shader debugging? Oh, that's a lot of hands, okay.
How many of you are on mobile? Oh, wow.
What about problems with thermals on mobile?
Wait, does thermals include battery life, or is that different?
Fitting within the thermal envelope and trying to figure out how to stay sustainable performance. Yeah, yeah. When you want to see if you made a change and you see like, is it better? Is it worse? How do I compare from run to run? That's a problem as well, right?
I think on that same topic, you know, you have like DBFS. In Android doesn't give you any ability to fix clock rates and things like that. It becomes very difficult, as you said, to reproduce the same results and do comparative analysis.
You're referring to the problem of you covered the vent for a second and then your performance is completely different.
I mean, just if you let your device cool down before you replay your capture, or you replay your capture twice in a row, and I mean, your clock cycle is going to be very different, right? Your clock frequencies, both CPU and GPU.
Yeah, on desktop we lock clocks, so you know that's kind of an easier. That just lock your clocks.
And you have huge fans.
And we're connected to a full plant or something.
Google is working on this, though. Yeah.
Yeah, so we have in that topic, there's a couple different approaches we are looking into, which is one of them is, for instance, if you capture a GFXR trace and now you want to replay it, one approach is to say, okay, like you want to replay the, let's say, Ian also mentioned this in his presentation. When you're replaying a frame, well, maybe the first time you replay it, you're actually in the wrong clock frequencies, so you may want to replay it over and over again. Well, even that might not give you the frequency, a stable frequency. You might need to inject some fake things here and there to warm it up and then make sure you're at a stable frequency and then do the replay your frame and then say, okay, or maybe you replay it many times and you see like, okay, statistically, I'm at this could be, I'm going to pick this one frame that seems like representative, and then you can compare to a better A/B testing. The other approach that maybe Simon you might want to talk about is more about frequencies. Fixed.
Yeah, so another thing that we're looking at is seeing if we can work with IHVs to come up with a set of clock frequencies that are within the right thermal envelope so that you won't actually get throttled at all, no matter how much work you push at it. And then also make sure that the clocks don't go idle either, because, you know, spinning the clocks up and down, that also affects behavior. So ideally, once you end up in that mode, you can do some analysis. Of course, your phone is effectively acting as if you stuck it in an oven in that point. So, you know, it's not going to give you as high performance as it would in a cold gameplay session. But if you're doing A/B testing when you're trying to see, you know, how can you improve performance, then at least you're getting numbers that you can work with without additional variance that you have to worry about.
I'm finding the whole like performance. How do I know my change is faster or slower? It's one thing I constantly find myself doing by accident is I forget to turn off shader caching when I'm testing like shader compilation speed, and I'm like, wow, it's really fast. And I realize, oh, I forgot to turn off the driver. If you aren't aware, if you compile a pipeline, most drivers, and you try to compile it again, the second time it'll be cached, and they'll look at that, you'll hash it, and it won't have to spend that time. But like, and then some, if you're on Mesa, like you can disable that, and that's how you can make sure it's actually running through the compiler. But like, that's like such a, you have to learn the hard way. So I don't even know if I had someone new who's new to Vulkan and just new to performance testing asked, how do I A/B test my change? And now you're talking about temperature envelopes. Like, I just feel like this is already a daunting task of like, it's like, you know, mad scientists to kind of work at this point. So I don't know what the answer is. I don't know how to like easily make performance testing. Well, Ian does.
Oh.
I'm not sure if so Cody, I'm not sure where Cody is, but he's done a lot of this, but I wasn't going to hit the testing part of it as much as just the analysis. One of the things that I did when I was working on Angle is we had meetings where we would collaborate, right? And somebody would figure out, here's how you solve this problem. And then we'd all do that, right? And here's how you look for this kind of problem. We'd all share that. Well, great. There's a handful of us now who have that knowledge in that area. But how do you do AI? well, AI trains on documents that you pointed at. It doesn't train on heads you stick a, something to pull that out of. And so we need that kind of database, I think, to try to help, right? And again, yeah, it's different on different GPUs, but most mobile devices are tilers. There's a lot of principles that count, like, gee, I don't want to do start and stop render passes and waste memory bandwidth, right? I'm sure there's a whole set of things that on desktop, same kind of deal, right? How do you put that information into a tool or a database or something that makes it so that I don't have to reinvent the wheel that somebody else already did 10 years ago?
So even if you're not getting the determinism, and so you get these results that are different, you're saying if you had like a metric that you could see what the temperature envelope was and where it might have changed the frequency, even that at least allows you to correlate to why you're not seeing the same data, like something like that?
That is one example. I remember one game I was looking at where I saw the same clock stair step every time I ran it. And it's like, okay, great. Now I can compare this step from run to run. But like what Emery was mentioning with the frame looping, we have an engineer who's spending some time trying to duplicate that. But that's just for trying to get A/B comparison, which is really important. But then, great, now that I do A/B comparison, how do I know why this is going slow? And there's a subtlety that can be very GPU specific, or just you have to have been there, right? You have to have worked with experts. How do we put that into a bottle and make it easy for everybody else to consume it? That's something that I would love to do. And as I've worked with some of the folks up on the panel, I've really tried to, hey, here's something I've learned, right? We ought to put that in the tool so that, yeah, somebody could use the tool like I would have used the tool, but how can we put a little bit of me or Charlie or Cody or somebody else who's done this into the tool so that it just says, hey, look, you're doing this, that's dumb, right?
I think, yeah, that kind of leads into the Android Gemini, or kind of the AI assisted, we're right on schedule, by the way. This is exactly what I had on the agenda. Kind of leads into that point, which is how do you actually provide some smarts into the machinery, right? How do you have it be able to map some of these seemingly, magical things that are happening in the background and correlate that to a user experience and something that they can do about it? If you have something that understands thermal throttling and they're able to kind of give you an idea of what that might happen, because I mean, yeah, maybe it's non-deterministic, but a user is going to have it out in the wild. It is an actual thing that can happen that you have to understand, analyze, and then do something in the tool about. So if you can track that information, I think that's useful. But then how do you relate that to the user in a way where you're providing guidance, right? Ideally AI assisted, because obviously that's the world we're in right now.
Well, maybe I can mention a couple of things. So the magic thing with AI, I think, like, has 3 legs on it. One of them is the recommendation, like the knowledge that's accumulated, right? It's like what Ian is mentioning, like the things that you learn from your team. If we can have more and more of those things, like, don't do that, this is wrong, this is the right way of doing it, that kind of information feeding in, that's one leg. Well, the other leg is runtime information, right? So if you have, if you're investigating a performance problem, well, the trace that you captured, well, you want to feed that into the AI so that the AI can have an understanding of it. But it's not always like, as you mentioned in one case, well, maybe there's a format problem, right? It's like, how does AI understand this? So maybe there can be wrappers around it, around the data that you collected, to make sense of it. So yeah, instead of looking at like binary blob that you just captured and then it comes back, it's like, how do you make sense? How does AI make sense of it? And then the third part is, okay, like, if AI is gonna give you some suggestions, maybe it needs to have more context on what your source code is looking like. And then when you bring that all together, then comes the magic moments, right? And you add the agentic behaviors, and then you start seeing the AI building hypotheses and then trying it out, trying if it fixes. If it doesn't fix, then it tries to learn from it and then iterates on it. So we have, you mentioned the AI in Android Studio that we have right now. There are certain moments where this comes into the picture. For instance, like if you have on the CPU side, we see this a lot. Like if you have a crash and it comes from production from Google Play, and then you have a crash on CPU side, we get the information, and then we can instantly say, okay, well, this looks like, looking at your source code, maybe you just need to fix these couple things. And then you don't even need to do anything. You just say, oh, it seems to fix the problem. Same for leaks on the CPU side, on the app side. Like when there's a memory leak that's discovered, it can just tell you, well, you just need to add a couple of lines to fix that problem. So that's the thing that I think we can bring into Vulkan, and then together with the knowledge base and the right set of abstractions for the data and the set of problems that AI can really shine there and help us.
So I want to ask a general question to the audience and kind of map it back to that. How many people here are using Cursor or any AI, Copilot, any technologies for just general code writing? A little bit, yeah. What about specifically for Vulkan? Few people. What about shaders like GLSL or Slang? Okay. More than just for general Vulkan, but that doesn't make sense because Vulkan, I'm assuming you're writing shaders for Vulkan. Would you say that incorporating these copilots into the standard Vulkan workflow would result in better success as far as understanding the code and providing these insights? Or is that just yet another thing where we have to have a large training data set, and you might find yourself in the situation where, you're getting non-deterministic behavior and then you're being given results that, don't make sense or don't point you in the right direction? I think that's everybody's fear, right? Is that you're like misled and then you spend many hours, down the wrong alleyway.
Well, I think one thing that it's important to remember is that even though in days of LLMs and computers talking back at you, it's not just LLMs that do this work, right? Anomaly detection is an entire field of machine learning and data science that can be applied at these problems, and that will give you concrete results. So we can apply some of those things as well. One of the things that I think the LLM world definitely applies, though, is if you don't know the name for the thing that you're trying to figure out, like it's great at taking like a very woolly kind of description of, if only I knew how like the memory bus on this GPU that I've only looked at twice and I don't know how the internals work. If I could just figure out how much like my pixel fill rate is affected by this and tell me which counters I need to look at to do that. Right. That seems like an amazing way to get an AI assist.
Well, it ties into education too. I mean, I think about profiles and I think about how you might say, I have a standard feature set that I want to support. And then you have to kind of like, what are you going to do? You're going to go read the profile, the spec of the profile, and you're going to try to figure out everything that I need to support. And then you're going to make sure that you have the capabilities in your code, but you're trying to do something that's non-standard. So now you're actually going to need the second profile, but then you're going to lose that many devices on the market. That seems like busy work, right? That seems like the kind of thing that you want the computer to do for you. What are more of those problems that we would want to see AI handle for us that we're just wasting a tremendous amount of time on? And it's not actually adding any value. It's just taking time for no reason. So going back to that problem of complexity, is that something where the tool should be involved in answering that question of, what does this extension do? And if there are new aspects of it that are kind of emergent, should the tool be instructing you about that? Or is that your job as an engineer? Or are you just going to use Copilot or, Cursor anyways?
One thing that we've seen in certain types of tooling, not really so much on the graphics side, but like especially on the CUDA side, is just not even machine learning based enhancements, but just scripting based solutions from the entire community of developers. So if the tooling is essentially scriptable or has plugin or Python capabilities, and you have a community that people can contribute to, open source sort of add-ons, we've seen that be very successful in other areas, and it's something we're talking about, wanting to go in that direction with graphics. I think that's the kind of thing that could also, merge with AI assistance as well. But I think, that the idea of like, I think you mentioned it earlier, that someone solved a problem, if they could write a little tool or rule or something that could be contributed, that is something. I mean, right now in Nsight Graphics, there's this plugin that basically takes a bunch of distilled knowledge from our team that's called the dev tech team that works very closely with the game studios, and that over the years they've created a bunch of rules about almost like what you were just saying about indicators of particular types of performance issues, what that what something in a report might mean specifically, why that's happening, and what you can do to solve that. And so these are rule-based systems, they're not AI-based systems, but having that ecosystem of the people on the front lines, if they can take that extra bit of time to encode that knowledge and get it into the tools, I think that's a really valuable thing.
Trace analysis is the feature, and it's an interesting one because it will point you towards the place that we think, based on the rule set, you might be having a performance issue. But I think the challenge with it has always been, well, how do we relate it back to the code? Because you still have to understand why the performance issues kind of emerge from however you were writing the code. So if you weren't using threading properly, or if your register pressure is too high, like we'll tell you register pressure is too high, and they'll be like, it might be these things, but we don't know because we don't understand your code. So how do you actually relate it in a good way?
I think graphics, more than a lot of other areas in development and just programming in general, has a lack of just volume of material out there, compared to Python or whatever. So there's less to train off of, or even just Google searching. And also, as we know from this conference, Vulkan is constantly changing. You wouldn't want to be given a bunch of advice based on old Vulkan. So I think for graphics, curation is going to be big, both for whether it's expert systems, scripting-based solutions, AI.
Oh, sorry, no, go ahead.
I was just going to say that on the scriptability aspect, one of the great things about having scriptable tools is that you don't have to wait for us to produce a new version if it doesn't support something that you need. And the other thing that's really useful about it is if you've got a continuous integration, continuous development environment, and you can do headless profiling and things like that, you can build this into your build system and just iterate and iterate and iterate. Somebody walks in the next day and they see, oh, my performance dropped 30% after somebody checked in this content. That's valuable information for you if you're developing any kind of game, right? Because you can, before things move on too far, you can say, oh, I know exactly what caused that problem, and I can go in and fix it.
That's exactly where I was going to take it, actually. And I was going to actually ask the Lunar G folks, we look at tools like RenderDoc where you can actually have direct integration with things like Unreal Engine. So there's literally like a button you can press and you get a capture from it. That ability to integrate the tools better, that interoperability between tools and these different, middleware or your game engine or, whatever Vulkan application you're developing, is that something that you are focusing more on because you see that ability to kind of harness that database of information that you could then mine or incorporate into those kinds of reports?
We're always discussing exactly what to do with the huge amount of information that's generated as captures. All of the hardware vendors have thousands of captures that they do analysis on. So there's an opportunity there. In fact, I was wondering as we were talking about this, boy, wouldn't it be great if there was a gpuinfo.org version of a thing where you could just upload your capture and it would just show up and you could see everyone else's.
Who would want that? Who would upload?
Not a lot.
Come on.
I think people might still be kind of learning what the value that would provide, so they might not totally.
So imagine a world where you can take a trace of your game and upload it to a central server, and that trace goes to different GPU manufacturers, and on their unreleased chips that you don't have access to, they can give you a performance report back that says, okay, this is how your game is going to behave on this.
Okay, all right, now hands are going out.
So you asked who would want it. Would I want it? Yes. Would my company's lawyers want it? Hell no.
Yeah.
Like we've talked about ways that we could like build corpuses of traces and the like, and certainly in angle testing, there's been a whole bunch of that. How you build a corpus of traces that does not contain somebody's IP in it is, and still exhibits the problematic behavior. So I don't know, we've got to have some texture that looks like the texture, but I don't know how you do that. Like,
Yeah,
so
that's
in an ideal world, would I love that corpus? Like, yes, it would be incredibly useful. Do I think we could practically build it? I'm less convinced.
yeah. There's a lot of distance between push a button and my textures didn't get exposed to the internet.
I mean, an open version of that for open source graphics and games applications would probably, I think, still have some value. But you could imagine for proprietary data sets, companies, the IHVs and ISVs having, protected, databases of these traces that they're using to improve their tools, maybe if in some kind of unified, lingua franca or whatever. So you could maybe achieve that with keeping people happy with IP protection, but also benefiting everyone from the results of that kind of training.
So we have an audience member with a point.
So Mesa, of course, has dealt with this problem of how to deal with traces that we can't really redistribute. And the ones that we can, we use them for performance regression testing along with correctness regression testing. So I have a repository of open source traces. It's not very big because we don't have that much of it. But if anybody has fully redistributable trace content they would love to see people using, TracesDB is the name of the repository on freedesktop.org. If you have a trace that you would like us to use in performance analysis and not share kind of outside of the community, there's another repository for that, and talk to me and I can sort it out.
So in other words, it's the database is you can get one, but there's these concerns about privacy, about IP protection, and yeah, I don't know that there's any way to obfuscate or anonymize a capture so that you wouldn't run into that issue, especially if people start kind of bundling things together. I mean, even the name of some executables, we know developers where it's like, don't share that name, right? So I think that is kind of one of the challenges with it. But are there, so we, internally, we have a thing we call a capture, and then we have a thing called a trace. Like they're different to us. A capture, you can replay. That's it. The trace is just a log. And so is this a category, therefore, that where maybe you can anonymize a trace a bit more easily because you start collecting, maybe those metrics that are represented on a timeline. And so at least you have something where it's just data. I can't relate it to a buffer or to a name of a resource. But at least it's information that we can analyze and be able to draw conclusions from.
Your database, is it specifically GFX reconstruct captures or? Yep, sorry.
So we mostly don't use GFX reconstruct because of how hardware specific your traces tend to be. So we have piles of GL workloads. We've got DirectX workloads that then you can run through DXVK. There's a couple of graphics reconstruct, I think, for specific hardware. But kind of, if you can get us content that we could replay, we would love that.
I think the overall theme I find around here is that we've talked about this a lot in the validation layers when we report error messages. A common complaint people have is like, you report an error, what should I do? And, sometimes it's obvious, like the value is null, don't make it null. But sometimes it's like, I don't know what you're trying to do. So there's like, sometimes these tools, they're just there to get the data. I mean, you're talking about like the difference between like a trace and a capture. Like there's tools that's just, I got the data, here it is. And then there's like, how do you analyze it? What do you want to do with it? So it's almost like a two domain or two part problem. Because right now, like, do you want to get the data or do you want to do something with the data? And so some tools are only focused on just the first part.
It compounds even worse into the idea that like one of the things we've talked a lot about, and we call it kind of like a holy grail kind of feature because it's extremely difficult, but it's the idea that Well, if you have a replay and it's just perfect, like you can just have a replay up to a crash. You can have a replay up to a performance issue. You could rewind to the, spot where there was a blip and a stutter happened. That's the ideal situation, but obviously it's an astronomical problem to try to solve. A lot of challenges associated with it. So are there strategies or ways in which Vulkan can be utilized to better instrument or provide metadata that can help us understand where these issues are happening? I mean, going back to interoperability and this idea of like, render doc and you press the button, is it more useful to have tools that you attach to an application and you gather information, you fill that database, or real-time monitoring tools where it's already embedded and you're able to react really quickly to anything that you might see?
It feels to me like those are both desirable things and you use them for different purposes, right? Because you have the observation problem when you're measuring things in real time, you're impacting the actual results that you're seeing. So sometimes you want to be able to do the gather and then do the analysis after versus the real-time analysis, because they just have different purposes and they have different side effects. So I think it's important to understand what problem you're trying to address before you answer that question, right? And so having both available is important. And a lot of the stuff that we've been talking about is focused on code-based feedback, but a lot of it's content that you really need to be analyzing. So a lot of these tools need to have a focus on providing feedback on the data that's being manipulated as opposed to the code path that's being executed. So I would like to put that out there as what are we doing about that from an ecosystem standpoint.
I think that's a challenge I hear about often as well is, we have a question over there. I'll fill time. The idea that, let's say, you have an Unreal Engine and you have your optimized backend, running Vulkan, but there's still more you could do to make it faster. But then somebody goes and runs a crazy material, like the artists just can do whatever they want. And so what is the tool's place in that? Because the complexity of the tool is perhaps too much for the artist, arguably, unless we start building all these layers of AI and other things that maybe can help understand or ground that information better. But the engineer is probably the one that's actually going to be able to make the really major changes in the underlying code base. And so I'll save more of that for a minute because I do want to ask more questions about it. But yeah.
Yeah, so maybe restating a little bit different spin maybe is I found that, so AGI and some of these new tools have both a system profiler, more of the Perfetto trace, and then the frame profiler, let's analyze your API usage, and they catch different problems, right? So stuttering is going to be found much more easily with the system trace. In fact, the one time thinking about A/B testing, I gave my one son who loves Genshin Impact 2 different phones, different software underneath the covers, right? You tell me which is which. Well, he told me very quickly, but in the process of then doing a system trace, found, oh, the shader cache is too small. That's why the game is stuttering, because it's doing shader compilation in gameplay, dumb thing to do. Which if I were going to give them feedback, great. But in terms of the Android operating system, it's like, okay, dumb thing for us. We didn't increase the size of the shader cache for 10 years, are bad. But then other things, the API usage, so important, right? And you're not going to see that with the system trace. Or with the system trace, you might say, gee, I have 10 render passes on this mobile hardware. Why 10, not 3? 3 would be better. That's where you got to go look at the API usage. RenderDoc, even your comment about it being a profiler, I've used it as a profiler when I didn't have the other tools. So just different way of restating.
On that point, by the way, the reason that I was mentioning, the conversation with Balder where, it's not a profiler, is because we worked with him to get the PerfWorks library integrated within RenderDoc. So you can get perf metrics in it. And he's like, but it's not, it's not going to be accurate. Like you have to, but it's an indicator, right? It points you in a direction and at least it kind of lets you know, well, maybe I should use system trace to understand a little bit better because something, a red light went off in the radar. I better look into it further. We're at the 5-minute mark, and I want to make sure to still open it up for general questions from the audience. So we can keep going up until the end, but I want to make sure if there are any things that people here want to cover, you get a chance to ask our amazing panel or just tell us about your experiences that you wish you had better tools for.
So yeah, speaking of better tools, one thing we would like to know if anything's planned for the future is like ray tracing debugging in RenderDoc, because that's been eating at us and it's like been a huge problem for us. So I wanted to know if like there's anything planned for it, and not just debugging, because on some NVIDIA hardware you can't even do any recording of it.
When you say debugging, are you talking about just general frame debugging or shader debugging specifically?
Shader debugging for ray tracing.
We have, at least in the validation layers, Arno, has been working extensively and trying to get it done this year, is GPU AV on validation layers, like, just basic stuff like, hey, you're just pointing at nothing and this is a garbage handle. That's one thing we plan to have, and that's hopefully, one of the tools that will help you. But yes, ray tracing, shader debugging is a very known pain point. I think it just goes back to, we've made a GPU centric, opaque system, and it's just hard.
So I don't think any of us can speak for RenderDoc, but we do have a Vulkan shader debugger in Nsight tooling, and it does support debugging ray tracing shaders. So we can talk during the conference, and we actually will.
We can show you
demonstrations of it as well. Yeah, but it is complex. It's a hard problem to solve. It's really hard, even with the tooling that we have. There's a lot of challenges to get that right. So it's a tough one. I mean, GPU development just feels so far behind CPU development, right? I mean, it just feels like 2026 and we're still nowhere close to what you can do with just developing regular old CPU code. So
how many folks in the audience are working on ray tracing right now? Oh, wow. Okay. Even I'm surprised. I mean, there are other platforms, I think, that do have good shader debuggers, but with, I think, ray tracing, the complexity and the challenges go up significantly. I think we have time for one more audience question.
We had one back here.
Oh, was there? Oh,
hello. Basically, when I have you in this room, why do we have so many different tools for doing developer?
So, we did talk about that. We talked about what profiler should you use for GPU, and I said, what profiler do you use for CPU debugging? Is there a golden single tool for CPU debugging? And I feel it's a problem. It's, someone says I can do this better and they just do it better. And I think it's the nature of it.
Well, I mean, I was gonna say render. Right, RenderDoc, but without ray tracing was the point. We try to allow Nsight graphics to work on, from AMD to Intel to NVIDIA, of course. And the things that can work relatively well are, basic Vulkan rendering without custom extensions. We're not going to support extensions, that we can't control. But then think about profiling. Profiling is where the major challenge starts to happen. Or I can go into shader debugging as well, because you have different internals for that, if you want to do hardware shader debugging, we don't have the same hardware that they have. But when you're talking about profiling, something as simple as the number of threads per SM or warp, is it 32? Is it 64? You can't relate them anyways. There are certain things like, shader pressure, register pressure, or you have L2 cache and all these other constructs that I think you can kind of map between the different IHVs. But in many cases, because the architecture is different, it makes it very much a specialized problem to that hardware, which I know makes it extremely difficult from a developer perspective. Again, it makes me wonder about that idea of, using AI, machine learning, LLMs to kind of help with that mapping as well. Because if you have something to translate for you, then, when you say, what is my performance issue? You're not asking for this hardware architecture. You're saying, because this is the core problem that I'm experiencing, and they have context and understanding of, both architectures and your code as well.
So would something like profiling intermediate representation work well for this? Like where the whole ecosystem basically speaks the same language when it comes to gathering traces and data. And not only like, obviously, if you capture a trace on NVIDIA and then try to replay it on mobile, it's not going to work. But doing the actual profiling on something that is standardized, would that be something that all vendors would benefit from?
I mean, Vulkan is actually extremely good at that. Vulkan, this is a conversation I had years ago where we were talking about like how portable are these Vulkan captures, and even the windowing system is Vulkan centric. So you're not just like, hey, Linux, give me a window, or hey, Windows, give me a window. You're like, Vulkan, I need something to display to, and it can kind of abstract a lot of that stuff. So it makes it a lot more straightforward. But for, we have a lot of different platforms represented here. I mean, from your perspective, what are the challenges of creating these tools that maybe are more useful from developers, in the interoperability perspective?
From an Android point of view, well, we have different GPU hardware, and the difficulty is that these hardware vendors implement things in a different way. And the way we try to standardize is through the process of having a CDD. This is the common interface. And you've seen Perfetto being mentioned in many ways. We have GPU vendors implement a specific provider that has to obey the certain CDD standards and provide certain data, be it counters, be it render stages, be it different information from the GPU. And each version of Android, we're trying to elevate this to the next level and provide more information in a more standardized way, so that with new versions of Android, we can provide more information to developers inside our tools, be it AGI or the next version of AGI that we are going to have. So it's more about, we are trying to do this cross-vendor in a vendor agnostic way, but the vendor-specific tools, they provide more depth. They have specialized capabilities based on their special hardware, and I think they can provide more details using those capabilities. And I don't want to speak on their behalf, but they have more abilities of showing more detailed data in that way.
So we are at time. I think I got to wrap it up. Sorry, everybody. If you want to talk more about it, catch us in the lounge area. We're happy to talk your ears off about it. I want to thank the panelists for being here and for answering all these questions. I want to thank you all for the great questions. And yeah, have a great Vulkanized. Thank you so much.